Welcome to the next installment of my video lecture series for microeconomic principles. And in this particular video lecture, I'm going to be taking a look at one of the potential test problems that could occur on test number 2, in particular chapter 13, monopoly. And the question would read something like this: assume a monopoly market and the firm in question is a profit maximizer. Graphically illustrate a firm operating at a profit or a loss. So there's two potential ways that this question can be written, using price, marginal revenue, demand, average total cost, and marginal cost. Be sure to show the areas of revenue, cost, and profit/loss. Explain your answer in detail. So before I do that, I wanted to go over just a little bit to make sure you understand why we're going to have a distinct marginal revenue curve in monopoly. If you recall, when I was talking about perfect competition, price equaled demand equaled marginal revenue in a perfectly competitive marketplace. And this was due to the assumptions that we made regarding a perfectly competitive marketplace. So for monopoly, remember, we have a downward sloping demand curve because the monopolist is a sole seller of a particular product, meaning the demand curve a monopolist faces is the market demand curve. So we have a downward sloping demand curve here representing the market demand curve. So this is the demand curve that a monopolist faces. The implication is that we're going to have a separate marginal revenue curve, and I just want to go over briefly so that people understand why we have a distinct marginal revenue curve. In order to accomplish this, what I'm going to do is calculate total revenue. So here we have price and quantity that represents the information that we have in this graph here. So for example, at a price of 10, quantity is equal to 0, just like here. At a price of 9, quantity is equal to 1, just like right here. And for all these points, they represent the data in the spreadsheet on the left-hand side. So as you remember, total revenue is just price times quantity. So if I take price and multiply by the quantity, that gives me total revenue. So at a price of 10, I sell nothing, so my total revenue is going to be equal to 0. So for all the remaining price quantity combinations, I'm going to do that calculation in a spreadsheet. I'm just going to copy this straight down. So at a price of 9, the quantity is equal to 1. 9 times 1 is equal to 9. At a price of 8, quantity is equal to 2. So 8 times 2 is equal to 16, and so on. So we did that calculation all the way through for every price quantity combination in this demand schedule. Marginal revenue is just the change in total revenue with the change in quantity. So to calculate that, we just look at, because the quantity is always changing by 1 here, so the denominator is always going to be equal to 1. We're just going to look at how much total revenue changes. So if we take the new total revenue and subtract off the total revenue from the previous quantity, that gives us our marginal revenue. And what this is telling us is that when we increase the quantity by 1, total revenue goes from 0 to 9, therefore the marginal revenue is equal to 9. When we increase the quantity to 2, total revenue is equal to 16, so 16 minus 9 is equal to 7. So I can repeat that calculation straight down that column to get what my marginal revenue is equal to. So when I go from a quantity of 2 to a quantity of 3, we can see the total revenue goes from 16 to 21. That gives us a marginal revenue of 5. Same thing when the quantity is equal to 4, total revenue increased from 21 to 24, therefore marginal revenue is equal to 3. So if I take that information, I can place this back onto this graph here on the right. So we can see that at a quantity of 1, marginal revenue is equal to 9. So at a quantity of 1, marginal revenue is equal to 9. At a quantity of 2, marginal revenue is equal to 7. So 2 and 7. At a quantity of 3, marginal revenue is equal to 5. So 3 and 5. At a quantity of 4, marginal revenue is equal to 3. So at a quantity of 4, marginal revenue is equal to 3. And at a quantity of 5, marginal revenue is equal to 1. Quantity of 5, marginal revenue is equal to 1. And what I can do is I can just connect those lines right there, roughly that point, and that gives us the marginal revenue. Now, as you notice, I'm not continuing the marginal revenue line further down to incorporate the negative marginal revenues. I'm just going to keep it in the positive range here. So this is our marginal revenue curve, and let me change the font on that to make it a little bit easier for people to see. So we have our demand curve and our marginal revenue curve. I just wanted to review that because some students have some issues understanding that. It's important to remember this because this is the key distinction between monopoly and a perfectly competitive marketplace. The assumptions in perfect competition cause the demand curve to equal price to equal marginal revenue, and in monopoly we have a distinct marginal revenue curve from the downward sloping demand curve. So make sure you're comfortable with that distinction. So as soon as you hear monopoly, you should be thinking downward sloping demand curve and a marginal revenue curve that's inside of the demand curve for a monopoly. Now the question itself was asking you to graphically illustrate a firm operating at a profit or operating at a loss. So let me bring up this particular OmniGraph Sketcher slide here. So we have our downward sloping demand curve and our downward sloping marginal revenue curve, which is inside of the demand curve. Now you see that I have them both starting at a Q equals to 0. For the purposes of our class, you really don't have to make it look exactly like this graph right there. So as long as you have a downward sloping demand curve and a marginal revenue curve inside of it, that's going to be perfectly fine. Let me actually change the header on this a little bit just so I can get a little bit of distance here. So let's assume that this firm is actually, this monopolist is operating at a loss. The easiest way to do that is just to draw an average total cost curve that is above the demand curve at every single instance. So if we have this as average total cost and it's above the demand curve, this firm will always be operating at a loss. So regardless of the output levels here, this firm is going to operate at a loss. And you might think, well, how can a monopoly operate at a loss? They're the sole seller of a product. It is quite possible. I know of at least one example of a workers' compensation fund in, I believe it was West Virginia or Virginia, for the coal mining industry. And it was mandated by law that it could not charge the correct price for workers' compensation insurance. It had to charge a much lower price. And what ended up happening is that workers' compensation firm lost money, and the state would reimburse it for the difference between, to cover its losses. So it was basically mandated by law that this workers' compensation fund that had a monopoly had to lose money, in essence just providing a subsidy to the coal mining industry in West Virginia or Virginia. So if we draw this average total cost curve in, also let's draw our J-shaped marginal cost curve. We'll draw it like that, and we will, remember it's a J-shaped marginal cost curve, so make sure you label it marginal cost. So you have your U-shaped average total cost and your J-shaped marginal cost curve. And remember that marginal cost should intersect roughly at the minimum of average total cost. So we have our J-shaped marginal cost curve and our U-shaped average total cost curve. And this firm is a profit maximizer, so it is going to set output where marginal cost is equal to marginal revenue. So where marginal cost intersects marginal revenue, if you go straight down, that will give you the profit maximizing output level. And let me put in the symbol for pi. I used to know the shorthand for this, and I've managed to forget. I guess I should go back and relearn that at some point in time. So this gives us our profit maximizing output level. And then once we have the profit maximizing output level, if we go straight up until we hit the demand curve, that will tell us what the price is going to be. So we get the profit maximizing output level where marginal cost intersects marginal revenue. So that tells us the profit maximizing output level. Once we have Q pi, we can go straight up until we hit the demand curve, and that will tell us the price. So we will call this P pi, P pi. And again, let me put that in. So the subscript pi for profit maximization, and that is the profit maximizing price. And let me actually move this up a little bit. All right. So that gives us the profit maximizing price and output level. If we continue this line upward, we will hit, let me draw a separate line in for that because I accidentally attached them. If I keep going straight up from Q pi until I hit average total cost, that will tell me what average total cost is for the firm. All right, so we have the profit maximizing price, profit maximizing output level, and we also know what average total cost is. So Q times average total cost is going to give us our total cost. So if we highlight that area here, that is equal to total cost. All right, so if we do average total cost multiplied by Q, that gives us our total cost, and that's this gray shaded area here. If I want to know what total revenue is P multiplied by Q. So I can bring that up, and let me change the color of that. Do a suitably annoying color. So here, this pink area in the bottom is total revenue. So we have total cost and total revenue. So if I take total revenue and subtract total cost, I can get the area of losses. And let me make it this color here. So this area right here is the losses that this firm is accruing. So make sure you're comfortable with that. Let me do the next part of this, and let me delete these out here. We're going to change this so that this firm is making a profit. So let me get this out here. And how we can do this is that we can just draw average total cost and have it below the demand curve. Let me move this over a little bit. So by having average total cost here below the demand curve at the profit maximizing output level, this firm is going to be making a profit. So we go through the same exact mechanics where marginal cost intersects marginal revenue, gives us the profit maximizing output level. All right, if we go up until we hit average total cost, that will show us what average total cost is and give us the area of average total cost. So this region in the bottom here is our total cost. And let me highlight that. So this area in here is total cost. And let me change that to gray. I think this is a little off. Let me move it down a little bit. There we go. So that area right there is total cost. Why? Because that area is represented by average total cost multiplied by Q, which gives us total cost. If we want total revenue is P times Q, Q times P. So the entire rectangle bounded by this region here, and let me highlight that. And let me actually change the color of that. So that area right there is total revenue. And actually, you know what? I think we'll make this a little bit easier if I did total revenue first. So let me draw in total revenue first. So total revenue is P times Q. So if we want to take a look at what total revenue is, it's the profit maximizing output multiplied by the price, represented by this area right in here, the blue area. If I want to come up with total cost is just Q times average total cost. So that area, and I'll make that gray, is this area down here in the bottom. So we have total revenue, we subtract off total cost, and what we are left over with and I will pick another suitably, oh, my apologies, didn't want to do that, forgot to unclick it. So if we take a look at that again, we have total revenue, we subtract off total cost. The difference between the two is going to be the profits, and I will make that green for moolah. So that area in green there is the profits for this particular firm. So make sure you're comfortable with that. Most students that have issues with this particular problem forget that when you assume a monopoly market, that you have a downward sloping demand curve and you have a marginal revenue curve that's inside of the demand curve. The other thing that trips people up a little bit is they forget what the profit maximizing condition is. The profit maximizing condition is where marginal cost is equal to marginal revenue. That gives you your profit maximizing output level. Once you get your profit maximizing output level, you can determine what total cost is because it's Q pi multiplied by average total cost, which gives you this region here. Total revenue is just the profit maximizing output level multiplied by P, which is the entire region underneath. And then the profits are the difference between total revenue and total cost.